Hello, we are discussing about GATE 2007 ECE paper, and the topic we are discussing is electron devices. This is 7th 2-mark question, came in GATE 2007. For the Zener diode circuit shown, the Zener voltage at knee is 7 volts. The Zener voltage at knee is 7 volts. The knee current is negligible and the Zener dynamic resistance is 10 ohms. If the input voltage Vi range is 10 to 16 volts, then the output voltage V0 ranges from A 7 to 7.29, B 7.14 to 7.29 volts, C 7.14 to 7.43 volts, D 7.29 to 7.43 volts. Given Zener voltage is 7 volts and Zener resistance is 10 ohms. If the input is changing from 10 to 16 volts, what can be the output voltage? So what is the minimum and maximum output voltage for the given input range? Correct answer for this one is 7.14 to 7.43 volts. Answer is C. We'll see the details. This is a circuit diagram where the input voltage is connected through a series resistor of 200 ohms. It is connected to the Zener diode, which is acting as Zener regulator. It is a simple Zener regulator circuit. And what was given is knee current is 0, that is IZ minimum, which is nothing but IZ knee, is given as 0, and at that point the Zener voltage is given as 7 volts. So VZ, Zener breakdown voltage, is given as 7 volts, and Zener resistance, dynamic Zener resistance, is 10 ohms. And if V input is changing from 10 to 16 volts, we need to calculate the range of output. When V input is equal to 10 volts, what is output? When V input is equal to 16 volts, what is output? We have to calculate those two values. And here the Zener diode is going to be a symbol. That symbol has to be replaced with equivalent model to know exact output voltage. So Zener diode equivalent model consisting of Zener voltage source along with a dynamic resistance, since both are given. So this is the equivalent circuit. Vi, which is nothing but Vs, here we have taken, and 200 ohms. Simply this Zener diode is going to be replaced with resistor and voltage source combination. And this voltage source, if you observe, this positive terminal of voltage source is nothing but negative N side of Zener diode, and P side of Zener diode is nothing but negative terminal. Since Zener diode is under reverse bias, because we are applying positive voltage towards N side, that's why Zener diode is under reverse bias. Under reverse bias only it can work as voltage regulator circuit. So by that time, while indicating, make sure that one positive terminal of the battery should be towards N side, negative terminal of the battery is towards for P side. So this is the equivalent circuit. Now we can write output expression from this one. V0 from KVL, we can write it as 10 times of I plus 7 volts. V0 is nothing but this point to this point, that is voltage drop across 10, current flowing through it is I. So 10 times of I plus 7 volts, where I is equal to current flowing through this one, I is equal to Vs minus 7 divided by 210. So this is output expression in terms of input. Now we have to calculate, if V input is equal to 10 volts, what will be the output? If V input is equal to 16, what will be the output? So when Vs is equal to 10 volts, V0 is 10 into 3 by 10. 10 minus 7 is nothing but 3. 3 by 2, 10 plus 7. So it is equal to 7.14 volts. So whenever V input is 10 volts, by that time output voltage is 7.14. Likewise, when Vs is equal to 16, in that output equation, substitute 16. 16 minus 7 is nothing but 9. So 10 into 9 by 210 plus 7. By that time it will become 7.43 volts. So the output range for the given input range is 7.14 volts to 7.43 volts. So the correct answer for the question is C. 7.14 to 7.43 volts. Thank you.